All right, so on question number 1, we start with this information here that VW, the length from V to W, is equal to the length from W to Y. So these are congruent segments. And then it also tells us that XZ is perpendicular to VY. So right here, it's making a right angle. That's what perpendicular means, and that's where those two lines are meeting. And altitude goes from a vertex, and it is perpendicular to the opposite side. So which line drawn inside the triangle is perpendicular to a side of the triangle? XZ. So XZ is the altitude. A median goes from a vertex to the midpoint of the opposite side. Do we have, guys, stop. Do we have a midpoint marked here? Did they say anything about a midpoint, or did they indicate where a midpoint would be? Yes, they did. W. Why is W the midpoint? Yes, VW and WY are the same length, which it told us right here. So that means W is a midpoint. So WZ or ZW would be our median. Explain why XZ is not a perpendicular bisector. A perpendicular bisector has to do two things. What does the perpendicular part mean? It means it makes a 90-degree angle. Does XZ make a 90-degree angle with our triangle? Yes. Okay, so we've got the perpendicular part down. But then it also has to be a bisector. What does bisect mean? To cut in half. Is X cutting this side of the triangle in half? No. So I would say because X is not the midpoint of VY. Okay, so that's why XZ is not the perpendicular bisector. Why is WZ not the perpendicular bisector? Correct. We miss the perpendicular part, but we get the bisector part. Because WZ is not perpendicular to VY. And then we get down to part E. It says the measure of angle YXZ. Y, then over to X, and then down to Z. So YXZ is this angle right here. How big is that angle? Right here. 90. That is a 90-degree angle right there. So in the place of the measurement of YXZ, I can replace that with 90. 90 equals 6R plus 12. Then I would subtract 12 from both sides. What is 90 minus 12? 78. So 78 equals 6r. Divide both sides by 6. And that means r is what? R is 13. Nicely done. Yep, we're going to do 2 and 3, and then we'll go do 7. Yes, because I was asked for 2 and 3 also. Number 2, use the picture to the right to answer the following questions. What is the name for segment AC? This segment right here. Well, I noticed this. What word comes to mind when you see that symbol? Perpendicular. And then I see these two things, which means C would be a what? Midpoint. Because those two segments, CD and CB, are congruent. So if C is a midpoint, what is C doing to segment DB? Bisecting it. It's cutting it in half. So you already told me that it's perpendicular, and now you told me that it's bisecting it. What would be in the name for this segment? A perpendicular bisector. Find the length of segment AB. So one of the properties of a perpendicular bisector is that any point that is on the perpendicular bisector of a segment is equidistant from the endpoints of that segment. So the distance from A to B, because A is on the perpendicular bisector, is the same as the distance from A to D, because B and D are the endpoints of the segment that's being bisected. So AB and AD are congruent. And what do we do with the measurements of congruent things? Set them equal. So the length of segment AB is equal to the length of segment AD. AB is 3.8x minus 16. And AD is 2.4x plus 12. We're going to get our x's on the same side, so I'm going to subtract 2.4x from both sides. What is 3.8 minus 2.4? 1.4, thank you. So I have 1.4x minus 16 equals 12. I'm going to add 16 to both sides. What's 12 plus 16? 28. So I have 1.4x equals 28. And then I divide both sides by 1.4. What is 28 divided by 1.4? 20. So x is 20. But that's not what they asked me for on this part of the question. What did they ask me to find? AB. Well, segment AB is 3.8x minus 16. So I'm going to do 3.8 times 20 minus 16. What do you get? 60. AB is 60. Part C says if the length of CD is 14.6, so right here, what is the length of BD? Here's CD, and I want BD. I want this whole thing. How many segments of size CD would fit in BD? 2. So 2 segments, 2 times CD is equal to BD. So I do 2 times 14.6, and that'll tell me the size of BD. What is 2 times 14.6? 29.2. BD is 29.2. Last part of this question, it says the measurement of angle DCA. D to C, and then up to A. How big is that angle right there? 90 degrees. So I'm going to replace the measurement of the angle right here with what its measurement actually is, 90, equals 6y plus 12. Then I'm going to subtract 12 from both sides. That gives me 78 equals 6y. Divide both sides by 6. This looks a lot like what we did up on number 1 on the last part. What is 78 divided by 6? 13. So 13 equals y. All right, we're going to do number 3 next, and then we'll go do number 7, and then I will take more requests. So flipping over to the back side of this page, it says use the picture at the right for the following questions. If CF, BD, and AG are all medians, what is the name of point E right here? This is where all 3 medians are coming together and intersecting. Centroid, yes. So that's my answer for part A. We learned about 3 special centers in triangles. We learned about the centroid, the orthocenter, the circumcenter, and the incenter. You have to know all 3 of those, and you have to know which line segments come together to form those centers. There are 2 questions on this review that touch on those ideas in their entirety. We can go and look at those after we do number 7 if you guys want to. All right, so when we had medians and centroid, this is where we did the 1x, 2x, 3x stuff. And medians hit what special points on the triangle? The midpoints. So this is a midpoint. This is a midpoint. And this is a midpoint. So BF is congruent to AF. AD is congruent to CD. And CG is congruent to BG. All right, let's label up our 1x, 2x, 3x stuff. If it goes from the centroid to a midpoint, is that a 1x, a 2x, or a 3x? 1x. What about if it goes from the centroid to a vertex of the triangle? 1x, 2x, or 3x? 2x. Because the whole median altogether is 3x. Is this right here an x or a 2x? X. What about this? 2x. This? 2x. And this? X. Beautiful. 3x is the whole median. You can't label that on the triangle. That's, if you look at the whole median right here, 2x and x put together gives us 3x. So it's possible that they have given you that segment over here or that they ask for it over here. But it's not one of the ones that we label because it would be the whole big long thing. All right. It says that EC is 20. Well, here's EC. Is that a 1x, a 2x, or a 3x? 2x. So 2x is equal to 20. Well, if 2x is 20, how big is x? 10. So the segment that's just x on that median would be 10. Which segment is the just x segment? EF. So EF is my segment labeled as x, so that is 10. From C to F, is that 1x, 2x, or 3x? 3x. And x is 10, so I have 3 times 10, which gives me 30. Part C, it tells me that AG, well, here's A and all the way over to G, so here's AG. AG is 21. Is AG a 1x, 2x, or 3x? 3x. So 3x is 21. Well, if 3x is 21, then how big is x? X is 7. From A to E, is that 1x, 2x, or 3x? 2x. So that would be 2 times 7, which gives me 14. How big is it from E to G? X, which in this case, x is how big? 7. Part D says ED, this right here, is 8. Is that 1x, 2x, or 3x? 1x, so x equals 8. BD would be this right here. 1x, 2x, or 3x? 3x. Yes, 3 times 8, which gives us 24. What about BE? 1x, 2x, or 3x? 2x. 16. 2 times 8 gives us 16. Perfect.
She told me she was done.
Okay, thank you. Part E. Part E says AF is equal to 3x plus 7. So right here. 3x plus 7. And AB, from here over to here, is 19. Are those two things equal? Should I set them equal or are they the same size? This is the same size as this? Then I can't set them equal. The only way I can set them equal is if they're the same size. How many segments that are this big fit into AB? 2. So if I had 2 segments the size of AF, that would be the same size or equal to AB. So we're going to do 2 times 3x plus 7, and that's equal to 19. We're going to take the 2 that's out in front of these parentheses and we're going to distribute that. Please make sure when you distribute, you're taking it to both pieces. I have a lot of people that are writing it down correctly, and we're forgetting to multiply the second piece. So 2 times 3x gives me 6x, but then we still have to do 2 times 7, which is 14. So 6x plus 14 equals 19. What do I do now? Subtract 14 from both sides. What is 19 minus 14? 5. And now what do I do? Divide by 6 on both sides. Does 6 go evenly into 5? So we can leave our answer as 5 over 6. Or you can write it down in its decimal form. Can somebody pop that into the calculator and tell me what 5 divided by 6 gives you?
It's
0.83, where the 3 is repeating. All right. Nicely done. Number 7, and then I'll open it up and take other requests. The first part of number 7, part A, this is something that we did at the very beginning of this module. We want to know whether or not the side lengths can actually make a triangle. So what we're asking is the sum of the two smallest sides. I want to know if that sum is bigger than the biggest side. Let me show you real quick what we're looking at here and why we care about that being the biggest. So if I have 3 side lengths, I've got a marker, a pencil, and then this pointer. These two put together, the pencil and the marker, you guys agree that that's shorter than this, right? Well, if I try to make a triangle with that, and I put it on the ends, no matter what I do, I can't make a triangle. If I make this side shorter, it's still my longest side. It's still longer than the other two, but now these two put together, the two shortest sides, are longer than my third side. And I can put it together to make a triangle. So the two short sides have to add up to be bigger than the longest side if we want this to make a triangle. What is the biggest side here? 3.9, the one down at the bottom, side RT. There's our biggest side. And so that means we're going to take the two other sides, which is 2 and 2.3. We're going to add those together. What do you get when you add those together? 4.3. Is that bigger than my biggest side of 3.9? Yes. So my answer to this would be yes. These side lengths can make a triangle. Part B comes from a different part of the module. It says list the angles of the triangle ordered from least to greatest. I don't have the sizes of any of the angles. How am I going to determine which angle is the smallest and which angle is the biggest? Yes, we're going to find the biggest side and the smallest side. Which side is the smallest side? 2. So if 2, side RS, is the smallest side, what's the smallest angle? T, the angle that is opposite that side. So here's my smallest angle. So since I'm supposed to be going least to greatest, I'm going to start with angle T. Let's go do the greatest. How will I find the greatest angle? Look at the biggest side. We already marked our biggest side. Which side is the biggest side? 3.9. So what's my biggest angle? S. Opposite the biggest side is the biggest angle. All right, so now we just have to fill in the middle. If T is the smallest and S is the biggest, what goes in the middle? R. All right. Is anybody interested in looking at the problems where we have to identify orthocenter and circumcenter and in-center and all of that? Okay, let's go look at number 4, and then we'll go look at number 14, which is the very last problem. So number 4 first. The 3 angle bisectors of a triangle, where those intersect, we call that the in-center. And the in-center is equidistant from each side of the triangle. Does anybody remember what we call it where the 3 perpendicular bisectors intersect? Close, but no. It does start with a C, but it's not centroid. Circumcenter. Circumcenter is where the 3 perpendicular bisectors intersect, and it is equidistant from each vertex of the triangle. Part C, this is the one that we talked about the least. The 3 altitudes intersect in something called the orthocenter. And finally, the 3 medians of a triangle. Does anybody remember this one? This is the centroid. And the centroid is the center of mass. Of a triangle, or the balance point. All right, so let's look at what this looks like now. Go to the very, very, very back page, the back side of the 3rd piece of paper. The points of concurrency are the in-center, circumcenter, orthocenter, and centroid. So we're going to look at these pictures. We're going to determine whether what we're looking at are angle bisectors, perpendicular bisectors, altitudes, or medians. And then based on that, we're going to decide which of these 4 would be the point of concurrency. All right, so let's look at the top picture. When I'm looking at this top picture, I notice these markings here. What do we use those markings for? To show congruence, yes. If this segment right here is congruent to this segment right here, what do we call this point? The midpoint. So what would this point be? Midpoint. And this point right here? Midpoint. So we have segments inside the triangle that are going from a vertex to a midpoint, from a vertex to a midpoint, from a vertex to a midpoint. What do we call segments that go from a vertex to a midpoint? Did this on the first question. What do we call segments that go from a vertex to a midpoint? Those are medians. Medians go from a vertex. Yep. To the midpoint of the opposite side. And this point right here in the center of the triangle where those three medians are intersecting, what do we call that? You can look back at number 4 if you need to. What'd you say? Centroid, yes. Where the three medians intersect, we call the centroid. The triangle right below it, I see these congruence marks again, which means that we call these 3 points what? Midpoints. But this picture has something that the one above it didn't. At those midpoints, I see right angle marks. What's another word that comes to mind when you see those right angle marks? What'd you say? Perpendicular. And what do midpoints do to sides of triangles? Cuts them in half. Give me another word that means to cut in half. Bisect. So what are these segments? Perpendicular bisectors. And what do we call the point where the three perpendicular bisectors intersect? You can go back and look at number 4 if you need to. Circumcenter, yes. So far, so good? Let's look at the third picture down. Does the third picture down show midpoints? Nope. Because I don't see any congruence marks on the sides of the triangle. Do we have anything about perpendicular here? Nope, no right angle markings. But I do notice something going on in each of these corners. They're being split into congruent angles. If they're being split into congruent angles, we would say those two little angles are, looking for an E word here. If they're congruent, then their measurements are equal. They would have equal measurements. They're the same size. So one bigger angle was cut to make two smaller equal angles. What do we call the line segment that does that? Go back and look at number 4 if you need to. What'd you say? Angle bisectors. And what do we call the point where the three angle bisectors touch each other? The incenter. Got one more. On this bottom picture, do we have angle bisectors in the picture? Do we have midpoints in the picture? No. What do we have? We have right angle markings. We have segments that are going from a vertex, and it makes a right angle with the opposite side. From a vertex makes a right angle with the opposite side. From a vertex, makes a right angle with the opposite side. What do we call segments that do that go from a vertex and make a right angle with the opposite side? If you go back and look at number 4, you should be able to use process of elimination to figure out what we're looking at here. Altitudes are the names of the segments. And what do we call where those intersect at? The orthocenter. Altitudes, just as a reminder, goes from a vertex it is perpendicular to the opposite side. Right. We are practically out of time. The answer key for this is posted in Canvas. So when you're in Canvas, you want to go to today's page, Tuesday, 12:10, review for Module 6, test day 2. Scroll all the way down to the bottom. And right down here is the Module 6 test review. Right here with all of my answers on it. Do you guys have to turn in the test? Due tomorrow when you come in to take your test?